everyone, today's lesson is lesson 40 and it's writing quotients with mixed numbers. I really appreciate this lesson because working with mixed numbers seems to be something that I notice students struggle with consistently, whether that be converting improper fractions to mixed numbers, just understanding what a mixed number is in general. When I say the words mixed numbers, what does that look like? And then really what are those representing and how do those relate with fractions? So this lesson does a really nice job just reviewing in general what a mixed number is and how we can solve using both pictures and a division equation. So writing quotients with mixed numbers. Now we're just going to start off remembering the word quotient means your answer when you divide. Let's take a look at our learning targets for today. Name a mixed number represented by a picture. Draw a picture to represent that mixed number, so just the inverse of that or the opposite of that. Write a quotient, so your answer when you divide, with a remainder as a mixed number. So really beginning that shift where we're not going to be using remainders anymore. Now we're at a point in your math where you won't need to do that anymore when you're writing the quotient of something. You will either start representing your quotients as a mixed number or as a decimal eventually. And then interpret the remainder for a given context. So always considering, what does your remainder mean? I gave this example a few weeks ago where I said you can't have like part of something. If you're doing like a story problem, for example, and it's about boats and you're deciding how many boats you're going to send out on the water, you can't have like 3 remainder 2 boats. You would just have to send 1 more boat. You have to kind of consider the remainder for a given context. Anyway, let's go ahead and take a look at this next slide. This is just not even an example problem. This is just a visual for you to kind of get an idea. The picture below shows some pot pies on a shelf. So we have a couple of pot pies here. Yum. There are 2.5 pot pies. So take a look. We have 2, meaning 2 full pot pies, and a half. Yep, that looks about right. This can be written as a mixed number 2.5. So right here, a mixed number is a number that's represented by a whole number part and a fraction part. That's why it's called mixed. It's mixed of a whole and a fraction. 2.5. Use a mixed number to name the number of shaded circles shown here. So I'm going to pause my video really quick. Even if you don't pause your video, I need you to take just a moment to mentally think about this. What mixed number is represented here? So taking a look here, you can see I've written the mixed number 1 and 1/2. 1, our whole number 1, of course, representing this whole shaded in area, and 1/2 representing this half of a circle shaded in. Example number 2 gets a little bit further into what does it look like to divide out with a picture a certain number of objects resulting in a mixed number, and then also we will check our work using just a division algorithm. So let's take a look at this example. Paco, Alejandro, and Lucy will equally share 7 chicken pot pies. How many pies are there for each person? Please pause your video and give this a try and unpause when you're ready to check your work. Okay, so what I've done here is just started, and I used the first initial of their name to indicate who gets the pie. So I started here. We have Paco, Alejandro, and Lucy. So I knew with this many pies, they were each going to get a couple at least. I could just kind of make that interpretation right away. So I started saying Paco, Alejandro, Lucy. Okay, they each get 1 full pie. Paco, Alejandro, Lucy. They get another full pie. We have 1 extra pie left over. There are 3 friends who are sharing these pot pies. Maybe these are tiny pies, I don't know. But we're going to take this last one, and because there's 1 pie left and 3 people, we need to divide this last pie into thirds, 3 parts. Let's see if I can do this. It's kind of tiny. Dividing circles into thirds always turns out kind of weird, like a peace sign, I suppose. Sorry about that. Oh, geez. Okay, so into thirds. So if I were to, not sure what just happened there. We have a pen. We have Paco. Okay, I've got a little bit of a pen delay apparently. Okay, sorry about that. So now I finished dividing out that very final pie into thirds, and I gave one section to each of the friends. We have Paco, Alejandro, Lucy. And once all the pies were divvied out, I went back and I just took a look at exactly what each person got. So just using Paco as an example, we have one full pie, and then 1 out of 3 pieces of this last pie. So altogether, each person got 2 full pies and 1/3, or 1 out of 3 pieces. I'm going to scroll down here and just show how we can check our work just using a division algorithm. Basically, what we had 7 pies divided by 3 friends. So we have 7 pies divided by 3, 7 divided by 3. And to do that, if we do our math correctly, we should get the exact same answer. So 7 divided by 3, how many times can 3 go into 7? 2. 2 times 3 is 6. 7 minus 6 is 1. Our whole number part is there, and this is where in the past you would have written remainder 1. But from now on, for now, we're going to turn this into a fraction. The number left over on the bottom, your remainder, becomes your numerator. It goes all the way to the top, and your denominator comes from this number out here, this divisor, 3. 2 and 1/3. 2 and 1/3 there, 2 and 1/3 there. Both methods will get you to the correct answer. Whatever is easier in your brain is the right model for you. Sometimes it's more appropriate to do the picture model, and sometimes it's more appropriate to do the division algorithm model. So it's important to show you both and for you to understand both. Let's give another one a try. A grocer divided a 5-pound block of mozzarella cheese into 4 equal pieces. Divide the 5 pounds, that's going to go here in your dividend place, by 4, divisor, and write the remainder as a fraction. So again, we're creating a mixed number. Please pause your video and give this a try, and unpause when you're ready to check your work. All right, so I've set up my problem. We have 5 pounds divided by 4. It's important to remember that in this story problem, we will have a label. We're talking about pounds of cheese. So let's remember that before we finish up our answer. 5 divided by 4. How many times can 4 go into 5? Once. Only once. 1 times 4, of course, is 4. 5 minus 4 is 1. And now we need to write our remainder as a fraction. So we're going to set up our fraction. This 1 goes all the way up to the numerator's place. And our denominator comes from this divisor out here on the outside. 1 and 1/4. Let me just double check and see. I think our label is pounds. Divide the 5 pounds by 4 and write the remainder as a fraction. So it'd be 1 and 1/4 pounds of cheese if we were to divide it by